Our sun shines, but how? Where does it get its seemingly limitless energy? What fuel burns in its center? These questions remained without answers until the 1920s, until physicists discovered that the sun, like the stars, draws its energy from the fusion of hydrogen atoms. This nuclear reaction, nuclear because it concerns the nuclei of atoms, is 1 million times more energetic than the strongest of chemical reactions. Scientists were drawn to this powerful energy source and sought to recreate it on Earth. The stakes are enormous. If scientists are successful in reproducing the energy of the stars, all of humanity would have access to a source of large-scale energy, one that is safe, available anywhere on the globe and in unlimited quantity, and without negative impact on the environment. While it is impossible to reproduce on Earth the exact conditions that make fusion possible in the core of the Sun, scientists have, in fact, found a way to recreate fusion in a laboratory setting. Beginning in the 1950s, the great and grand fusion adventure began. In the Soviet Union, the United States, Europe and Japan, scientists built fusion machines, machines that were more powerful and more finely tuned as the years passed. They all had one thing in common. They exploited the properties of plasma, the fourth state of matter. A plasma conducts electricity and reacts to magnetic fields. By heating a plasma to very high temperatures, over 100 million degrees Celsius, and by confining it with intense magnetic fields, conditions are created that make fusion possible. The fuels of magnetic fusion are two isotopes of hydrogen, deuterium and tritium. Deuterium can be extracted from water and is available universally. Tritium can be obtained from lithium, a metal that is as prevalent as lead on our planet. The Iter tokamak is the culmination of decades of fusion research. For the first time in history, the world's largest nations, China, Europe, India, Japan, South Korea, Russia, and the United States, have joined together to build the machine that will prove that fusion energy is feasible.
Je suis particulièrement heureux de vous accueillir aujourd'hui pour la signature de l'accord international Iter.
In 2005, the Iter members unanimously decided to build their project in southern France, near Aix-en-Provence. The dream of 3 generations of international fusion scientists is about to become a reality. A small sun will be created in Provence that may well write a new chapter in history. Iter construction is underway. 2 years were necessary to prepare the 42-hectare Iter platform. In August 2010, work began on the first buildings. Another 8 years will be required to complete the scientific installation and to assemble, test, and commission the Iter device. Iter is one of the largest engineering and construction projects in Europe today. The seismic foundations are in place for the Iter tokamak. A large factory building is ready to house the winding and assembly of the largest Iter magnets. And the assembly building foundation slab is ready to receive the large, specialized tools that will be required during machine assembly. Beginning 2014, over 3,000 workers will participate in the different building projects underway on the platform. In a strong show of support for the Iter project, the new headquarters building was inaugurated in January 2013 in the presence of the EU Commissioner for Energy and the French Minister of Higher Education and Research. While work progresses in southern France on the scientific installation and facilities for Iter, manufacturing progresses in Iter member factories all over the world. Components will be delivered in kind to the project by the members. Instead of providing the monetary value of each system or component, they will deliver the completed components to the Iter site to be assembled in what is certainly one of the most complex jigsaw puzzles ever conceived. The largest components will arrive by sea and be unloaded near Marseille. From there, they will travel to Iter along the 100-kilometer Iter itinerary, which has been specially adapted by France to receive the exceptional size and weights of the load. The delivery of the first completed components is scheduled in 2014. From that moment on, approximately 6 years will be necessary to complete the assembly, testing and commissioning of the Iter device. The first years of Iter's operation phase will be dedicated to the production of non-nuclear plasmas, hydrogen, helium and deuterium plasmas. This phase will allow for the fine-tuning of the machine and the testing of the most promising physics regimes. The nuclear phase will begin in 2027 with the introduction of the real fusion fuels, an equal mixture of deuterium and tritium. 15 years of fusion experiments are planned to exploit the full potential of the Iter machine and to provide data for the next phase machines, the demonstration fusion reactor demo, and the future fusion production plants planned for the second half of this century. On the road to the commercial production of fusion energy, Iter is an essential step. 34 nations are working hand in hand to realize the project in southern France. Iter is their answer to the challenge of the century: how to produce large-scale energy for future generations in a cleaner and more sustainable way.